In this video, we'll discover loops, an extremely important and common programming language construct. I think it was Edgar Rice Burroughs who said in a famous quote that humans are a creature of habit. Habit implies that we love to do things repeatedly. For example, having tea or coffee in the morning when we wake up, reading a newspaper, listening to music while driving, and so on. In fact, life itself is made up of actions we perform in repetition. Everything from dawn to dusk, going to school, college, or the office, eating breakfast, lunch, and dinner, going to bed, and waking up the next day, and so on. So, if you think about it, you're essentially living in a loop where you repeat a lot of things every day. Even in nature, water evaporates from our oceans, forms clouds, rains on land, flows back to the oceans, and the cycle repeats. Now, let's take the example of something as simple as washing dishes after a meal. You pick up one dish, wash it thoroughly, and keep it on a rack for drying, and then you repeat the same thing. Let's say you have a fancy robot who can wash your dishes and you can instruct it using pseudocode. The basic recipe or workflow for washing a single item might look something like this: get a dish to wash, wash the dish, place it on a rack to dry. Let's see what it might look like in pseudocode if you could program this robot. Here, the actions wash and put are all hypothetical because we're in pseudocode land and we can literally do anything. So imagine wash is some feature that instructs our robot to wash an item, and then put makes the robot place the item somewhere. This will wash one single item. So, how do we wash 3? Well, we could simply repeat these instructions thrice, and this would work. Pretty simple, isn't it? But now, let's say our robot is in a restaurant setting and we've got 100 items to wash, and you had to write the program. Repeating these instructions 100 times is simply a nightmare to say the least. Instead, what if you could instruct your robot to just repeat these set of instructions 100 times? This solves the problem without needing to repeatedly write code that does the job. And this is what loops allow us to do in computer programs. Loops allow us to run a series of instructions multiple times. They are part of control structures in programming because they enable the program to control the execution based on conditions. In pseudocode, we can express loops in multiple ways. The first one is the for loop. So coming back to our dishwashing robot, if we had to instruct our robot to wash 100 dishes, we could do this. Notice how indentation plays an important role here. The for and end for create a code block, and anything inside this block will be executed as many number of times as this loop runs. In this case, we are simply counting from 1 to 100, so the statements in the code block will be executed 100 times. The statement every number between 1 and 100 is a condition under which the loop will continue to run. When this condition is no longer satisfied, this loop stops running. So our robot is now happy, and in the simplest possible way, we've made it wash 100 dishes. Now coming back to the world of programs, a program like this would simply display numbers 1 to 10. And what if we want to compute the sum of numbers 1 to 10? Well, we could do this. Here, we are first creating a variable called sum and setting it to 0. This is our bucket which will hold the sum. We then create our for loop, and on every iteration of the loop, we simply take the current value of sum and add the current number and then store it back to the variable sum. The first time this runs, number would be equal to 1. Hence, sum would now hold the value 1, which is computed as the value of sum plus the value of the number. On the next cycle, number becomes 2 and sum would become 2 plus the current value 1, hence sum becomes 3. On the next cycle, number becomes 3 and sum becomes 6 because it's already holding the value 3 and we are adding 3 from the value of the number. Once the loop ends, the display statement shows us the total value as 55, as you can see here. Now, here's something you'll find interesting. The for loop in pseudocode is derived from the for loop, which you can see in most programming languages. So our program to compute the sum of numbers 1 to 10 looks like this in JavaScript. Notice how it is quite similar to our pseudocode version, but implements programming language specific features which you will learn in due course of time. Okay, moving on to the next example. Let's say we have a list of 5 random numbers. Here I've represented them as an array data structure storing in a variable named random numbers. We can get the for loop to run through the list and display the sum of all these numbers. Here the for loop is being made to run through a collection of items such as a list of numbers. Now, just like the for loop, we also have the while loop, where you keep looping until the specified condition evaluates to true. Here, we have created a program that takes a variable called x and keeps running the while loop until the value of x stays less than or equal to 20. Since we are not modifying the value of x anywhere, this specific program will keep looping and will ultimately crash. This is because, unlike the for loop, where programming language features offer a way to increment the counter that runs the loop, here in the while loop, you, the developer, are in charge of the counter. So we'll modify this program to include a mechanism for incrementing the value of x at every iteration of the while loop. In pseudocode, you can just say increment x by 1, and it explains what we're trying to achieve. This now causes the program to display numbers 1 to 20. And just like the for loop, programming languages do offer the while loop as well. Here's our JavaScript equivalent for this example. So let's work through a problem. Our program should compute the total payable amount for a list of 3 items where the base cost and quantity is provided. We'll begin by a variable holding our list. Here we are doing things visually. However, in a real program, you would hold such data in a data structure such as an array full of hash maps, for instance. We'll keep things very simple here. Next, we'll create a variable which holds the total payable cost. We'll initialize it with the value 0. Then we loop through the list using a for loop, and at every iteration we pick up the cost of the product and the associated quantity, multiply them together and add it to the value of total payable. Once the loop ends, we'll display the total amount using a display statement. Now, where do you see such functionality? Shopping carts on sites like Amazon employ similar logic when they display the total payable cost of items that you've purchased. Simple, right? So, to sum up, loops are required for processing multiple elements. Loops enable you to execute a series of statements repeatedly until a condition isn't met. The for and the while loops are the most common types of loops, which you also find in real programming languages. Think of places where you might want to use loops to simplify your work. In the next video, let's take a look at conditionals.